All right, welcome back to ABA exam review and the continuation of our BCBA exam practice series. If you're new to the channel, welcome. If you're returning, welcome back. Please like and subscribe. Check out behavioranalyst.study.com for all of our study materials, including our combo pack. When you pass, let us know so we can include you in the Sunday shout out. Work hard, study hard. Let's get going. When graphing data on an equal interval graph, which of the following is true? All right, this is a must be true question. When we get questions that say is true, is false, one of these has to be true, right? Or one, and if one has to be true, then the other three have to be false. That's how we want to look at these type of questions. Now, the hardest part about this question is what's an equal interval graph? An equal interval graph is simply a line graph, the most common type of graph we use in ABA. So if we have a question like this, it says one of these is true. Let's look at the three that are false. A, you're unable to spot trends on an equal interval graph. Well, this type of graph is great for spotting trends. This might be slightly upward, and then we can see when it moves down, back up. Great for spotting trends. B, an equal interval graph is best used to find correlations between time of day and behavior. Which one of our graphs is used typically to find out when behavior happens given a point in the day? Well, that's going to be a scatter plot, because with an equal interval graph or a line graph, we're typically measuring over the course of time, not necessarily at a point in time. So a scatter plot is better than a line graph at finding correlations between time of day and behavior. C, behavior is graphed on the y-axis, while time is graphed on the x-axis. That is true. Behavior goes here on our y-axis, while time goes on the x. So we know that is true. And then D, an equal interval graph is great at using solid columns to compare frequency data for multiple learners. What type of graph is that? Well, that is our simple bar graph. So not too difficult of a question, but we've got to read carefully and pick the one that is true. And we have to be familiar with what an equal interval graph is. So the answer here is behavior is graphed on the y-axis, while time is graphed on the x-axis. You decide you're going to use a punishment procedure after evaluating your other options. You need to target a child's running away behavior that occurs in public places. When selecting an alternative behavior, what is not true? All right, we had a question that asked what is true. Now we have a question that is asking what is not true. So this is a must be false, right? Three of these will be true. One is going to be not true. Let's identify the ones that are true. And what do we know? We know we are going to use punishment to target a child's running away. And we want to know what is not true about alternative behaviors. A, the alternative behavior should be functionally equivalent to the running away behavior. That is true. We want functionally equivalent replacements. B, the alternative behavior should ideally be easier to perform for the child compared to running away. That is also true. When you're choosing a replacement or an alternative, you're hoping that the alternative is easier with lower effort for the learner. C, you need to choose at least 3 possible alternative behaviors to reinforce. That is not true. Especially in the beginning, if it's very challenging, you might only want to focus on one behavior to reinforce very strongly. So C is not true. D, you should consistently reinforce the alternative behaviors. That is true. So the one that is not true, given our 4 choices, is C. You need to choose at least 3 possible alternative behaviors to reinforce. A data entry intern is trained on how to properly fill in Excel sheets at the end of each day. The intern demonstrates proficiency after a couple of days, but 3 weeks later, the intern is placing data in the wrong spots. What is most similar to this situation? All right, we have a very applied question, right? Because we're not necessarily talking about clinical work or interventions. We're talking about an intern who's taught how to fill in Excel sheets. They demonstrate proficiency so they can do it, but then 3 weeks later, they're now doing it wrong. What does that resemble? When we train on something, it's done correctly, but over time, errors start to pop up and things start to change. A, treatment drift. Yes, this is similar to treatment drift. We have technicians all the time. We teach them They demonstrate proficiency. They're great, but over the natural course of time, things change. How we're implementing it might change. It might be implemented incorrectly. Small things might differ from what the original plan looked like. In this case, the intern is no longer putting the data in the right spots, but rather they're putting them in the wrong spots. That is just the natural occurrence of treatment drift. It's one of the reasons we need to supervise very closely to make sure our treatments are being implemented correctly. Observer drift has to do with measurement. This is not a measurement issue, right? Observer drift is when we start measuring differently or observing something that we should not be observing. Reactivity has to do with reacting to something in the environment just because it's there. Not the case in this question. And then observer bias. There does not appear to be a bias issue. It's simply an issue of treatment drift. The intern who was once proficient at the skill and at the plan is now doing it incorrectly. Just over the course of time, things tend to change. Ricky wants to present the weekly frequency of aggressive behaviors displayed by a client over the past 2 months. She wants to clearly show the number of aggressive behaviors per week to highlight the changes over time in a format that is easy to analyze for the stakeholders. Which type of graph would be the most appropriate for visually comparing these weekly data points? All right, we have a graphing question. And graphing questions should not be that challenging, right? Visual analysis questions, graphing questions should be fairly straightforward. We just have to think carefully about what we're trying to show. In this case, Ricky has weekly frequency of aggressive behaviors over the past 2 months. She wants to show those behaviors per week to highlight changes over time in a format that is easy to analyze for stakeholders. So if we have batches of frequency data and we want to compare those batches of data, what's going to be best? Well, let's think about a bar graph. If I have week 1, week 2, week 3, week 4, that's pretty good, right? And then we can go on for all the months. A bar graph is very good at taking batches of data and comparing those batches of data to other batches. It's very easy to compare that. Cumulative record is not going to be successful at this because this is just a record that continues to go up. It's just a running total. A scatter plot is not going to be able to compare these very well. If we wanted to know, let's say, a certain cluster of time that these occurred at or certain situations, scatter plots would be better. But for this objective of showing or comparing changes per week, not going to be great. And then a line graph is over time, right? So yes, we might see a trend over time, but this is weekly, and we're not typically going to graph weekly data, right? Typically, our line graphs are much more consistent as far as our time goes. Could you use a line graph? Yes. What's the better way to compare it? Compare a cluster of frequency data to each other? That's going to be a bar graph. 2 behavior technicians independently collect data on on-task behavior during circle time using a precise operational definition and duration measurement. However, both technicians record 15 minutes when the duration was actually 12 minutes. What is the issue with the data? Good data are accurate, reliable, and valid. Accurate says we're measuring exactly what happened, the true value. Reliability says we can measure the same thing over and over again. Validity says we're measuring the correct thing. And then IOA is all about believability. What are we missing here? We have technicians collecting data on task behavior using a very precise definition and duration measurement. So that implies that they should be able to measure exactly what they're looking for and hopefully reliably. We're not sure though. What we do know is they recorded 15 minutes, but the actual duration was 12. So knowing that they didn't record the actual value or the true value, what was the issue? Well, they lacked accuracy. We don't know about believability. We have both of them recording the same thing, so it seems believable. Doesn't mean it's accurate. And we don't really know if it was reliable or valid. What we know for sure, though, is it wasn't accurate, so the data lacked accuracy. An educational psychologist conducts a study in a 30-person college-level biology class to investigate the impact of different lighting conditions on test-taking speed. Preliminary results indicate lighting has an effect on test-taking speed, but now the psychologist wants to know more about the external validity. How would they learn more? Long question, a lot of stuff going on. Let's focus on what the question wants to know. They want to know about external validity. How do you learn about external validity? Well, external validity just has to do with the generalization of the intervention or the outcome. And when you start breaking questions down like that, simply saying, well, what does the question want to know? They want to know about external validity. External validity is just generalization. It becomes pretty straightforward. So if this educational psychologist wants to look at these lighting conditions or these results and prove external validity, we've got to think about generalization. So A, repeat the experiment several times in the 30-person classroom. Well, if they repeat the same experiment in the same place with the same 30-person classroom, that's not going to prove generalization. B, make sure that there are no confounds potentially impacting the results. Confounds are much more related to internal validity and that functional relationship. C, remove the intervention and retake data. Well, that's just going back to baseline, not proving anything about the intervention. D, repeat the experiment in a physics class. Yeah, this would be our generalization test. Can it translate to a physics class? And again, once we start to break down questions like that and not get caught up in the details, the test becomes so much easier. Then it's just a definition check. Do you know what external validity is? How do we check for it? And that's it. An analyst who specializes in business behavior management is hired by a retail store to increase productivity from the staff. The first thing the analyst wants to do is familiarize herself with the store itself. What type of assessment should she use specifically? When we're thinking about assessments or analyses, we want to know what are we trying to accomplish? That's your question. Do you want to know what someone likes? Do you want to know what's reinforcing? Do you want to know the function? Do you want to know the target behavior? If you ask yourself, what is my assessment goal? It becomes very straightforward. What are we trying to accomplish? What's our goal? The goal here is the analyst wants to familiarize herself with the store, not the people, not the behaviors, none of that, with the store. So she wants to know about the environment. If we want to assess the environment, what are we going to use? A survey assessment. Well, we can't survey the store itself. It's not going to be a lot of use. B, a direct assessment. Sure, she can go directly observe the store, but what specifically, keyword, is she going to use? C, a functional analysis. She's not looking for the function of anything, right? She's not manipulating variables. What the analyst is doing is an ecological assessment. The ecological assessment assesses the environment rather than, let's say, the people and the behaviors. Johnny is measuring a toddler's tantrum behavior over the course of a 6-month intervention designed to reduce the frequency of tantrums. By the end of the intervention, the tantrums have significantly decreased. However, the analyst is unsure if this reduction is due to the intervention or simply because the child has become more developed. What potential threat to internal validity is the analyst considering? We can start to tie all of what we've learned about independent variables into this idea of internal validity. Internal validity says our IV should be affecting our DV, but there are plenty of threats to this effect, right? What other things can affect our dependent variable? Things like maturation and history, testing, attrition. Attrition, for example, if we have people dropping out of our study, our proof of functional relationship may decrease. Testing, how we're actually measuring or testing, or what instruments we're using to measure the data. History has to do with the learning history, the past of our participants. Maturation has to do with the growth in the future. So if we have a situation where Johnny has this toddler and the tantrums have decreased, but now Johnny or the analyst is thinking it might because the child has become more developed over the time. Well, now we're talking about growth. We're talking about the child's future. We're talking about maturation. Internal validity questions. Again, it's a concept question. We want to know what is the internal validity and then what are some threats. And if you know your threats, then it becomes very easy because these threats, luckily, aren't all that similar. So the threat here is the child's growth or future or maturation. Claire wants to be Bingo from the show Bluey for Halloween. She wants her dad to wear a Bluey costume with her. Her dad tells her that he will wear the Bluey costume if she doesn't get any red stamps at school that week. What is the dad using? All right, easy question. Guys, these have been challenging. We finally get an easy question. When you get an easy question on the exam, don't overthink it. Use it as a moment to take a breath. Trust your prep, answer the easy one, move on, buy yourself some time, right? So we have a situation. Dad says, if you don't get any red stamps, I wear the costume. So when we have an if then statement, what is that called? Well, that's a contingency, right? And we're always setting up contingencies. If you do this, then this happens. First, you do this, then this happens. Why is this not a bribe? A bribe is the opposite, right? It's like then if, right? A bribe would say, okay, I wore the costume. Now you have to go be good at school. You already gave the reward prior to the response. We don't want that. We want a contingency. The response needs to happen first. Don't get any red stamps, and then the reward. That is what a contingency is. A nutritionist is looking to explore the impact of diet on reducing restlessness in children. The nutritionist chooses to use a single case design instead of a group design to conduct this research. What advantage might the researcher gain by using a single case design over a group design? In behavior analysis, we favor single case designs over group designs. Does that mean group designs are bad? No. Does it mean single case designs are perfect? No. But there are some advantages when using a single case design that we like to take advantage of. In this case, this nutritionist wants to know the impact of diet on restlessness in children. What advantage might they gain with a single case design? A, the nutritionist will be able to generalize the results to a larger population. With the group design, you're usually taking a sample and then generalizing that to a population. Single case designs are much more focused on individuals, which makes it more difficult to generalize. So A is not an advantage. B, external validity is easier to prove with a single subject design. Not necessarily true, since each person is their own control, and we're much more focused on the individual outcomes rather than the outcomes of others. C, it reduces the need for repeated measurements. One of the characteristics of single case design is repeating over and over. That's one of the benefits of working with small groups or individuals is you can have time to repeat. One advantage of the single case design, given the other three were not an advantage, is going to be it requires fewer participants. You can do single case designs with one person, right? We can do withdrawal designs and change criterion designs with one person. That is an advantage. Again, group designs aren't bad. Single case designs aren't perfect. There are just some advantages we use or we like with single case designs in ABA. Thanks for watching. Be sure to subscribe. Check out behavioranalyststudy.com for all of our study materials. When you pass, let us know so we can include you in the Sunday shout out. Work hard, study hard. See you soon.